We're going to continue looking at force 4.3, and we're going to focus on frictional force. The objective says to explain that friction is a force that opposes sliding between two surfaces, and for surfaces that are sliding relative to each other, the force on an object always points in the direction opposite of the relative motion of the object. Calculate friction from force diagrams. So basically what this means is if I have this eraser and it's simply at rest, my object is not actually experiencing any friction. It is, however, experiencing our next force in 4.3, normal force. So in order for this object to experience friction, we have to have some sort of motion so that the friction is opposing the motion or the sliding between the two surfaces. If this eraser were resting on something that had a slant and it was just sitting there, it would in fact be experiencing friction because it is again opposing the sliding of the motion. So if we look at this in terms of free body diagrams, kind of looking ahead at this concept, our little square here represents our object, whatever that is. In this case, it's the eraser. And if, say, this is the direction that I push the eraser, I'm going to call that the applied force. And I label that applied force as F of A. And the applied force can equal a push, it could equal a pull. In this case, I was pushing the eraser in that direction. So that means then that my friction is going to be in the opposite direction of the applied force, and we call that F of F. Now, there are a couple different scenarios here for what could be happening as far as the friction, so I'm kind of looking ahead at 6.1 and 6.2. If the applied force is greater than the frictional force, then the object is going to be speeding up in the direction of the push or accelerating. If the applied force and the frictional force are equal, the object could either be experiencing constant velocity or it could be not moving at all. And then finally, if the frictional force is greater than the applied force, the object is going to be slowing down, meaning the friction is larger than the applied force and it's going to eventually slow it down. Now, the last piece of this objective says that you need to calculate friction from force diagrams. So, here's a scenario. I have an object. Let's say the applied force is in the positive direction with 40 newtons. We don't know what the frictional force is, but we do know that the net force is positive 35 newtons. So if I know the total force is positive 35 newtons, and I know that the applied force is positive 40 newtons, I really have to do positive 35 newtons, our net force, minus positive 40 newtons, which would then give me negative 5 newtons. So in this case, the frictional force would be negative 5 newtons. If I had another scenario, let's say similar object, the applied force this time is going to be going in this direction, and it has negative 20 newtons of force. The frictional force is unknown, but I know the net force acting on that object is 0 newtons. Well, 0 newtons minus 20 newtons, 0 minus a negative 20 newtons, would be positive 20 newtons. And that totally makes sense, because if I have positive 20 newtons of frictional force, negative 20 newtons of applied force, my net force would be 0 newtons. And that wraps up frictional force of 4.3.